Hello everyone, this is lecture 5. And the plan for today is to talk about strings, to talk about lists. And again, I'm borrowing my lectures and my notes from Mariam, lecture notes from previous years. So what are lists? We already talked about lists. So lists are basically ordered sequences of arbitrary data. This can be list of numbers or maybe list of strings. It can be an empty list. It can be also a list of mixed type, so it has both strings and numbers. But somehow this is usually not recommended. So we'll usually stick to one type. One thing I would like to say is that lists are mutable. Mutable means we can change a particular entry in a list. Okay, so lists are, of course, they're very common data type because somehow we need list of students or list of grades. And the syntax, well, this is the syntax, right? This is how you create a list, and this is how you assign a variable to point to this list. Right, so as I said, lists may have different types, but usually we don't do it. We like to have lists of that all items are of the same type. For example, list of integers or list of strings, so in this case colors, or list of booleans, or this is a list of floats. Yeah, we can have different types, for example, a string and an int, and even another list inside the list, and another string, another int and a string and a boolean, but this is not recommended. This is usually confusing. One thing we'll touch on this later is that lists can contain lists inside, and in this case, so these are kind of nested lists. And in this case, we can think of it as two-dimensional list. Namely, this is the first row, this is the second row, and this is the third row in a matrix. Okay, so a matrix is just a list that contains where each element is one row in the matrix. How do we access a list? Well, using indices, right? So this is index 0, this is index 1, 2, 3, 4. So we start from index 0. Right? So index 0 is 11, index 2 is 24, and so on. For example, if we want to print, we print using print numbers in position 0. So there should be brackets here. I think this with no brackets is some older version of Python. There should be brackets. Nice thing about lists is lists are mutable. Let me do this example. So my debugger working? Yes, it's working. Good. So I have this list, and the indices are 0, 0, 1, 2, 3, 4, 5, 6, and so on, up to the length of the list. So for example, we can print the list. So one way to print it is, okay, there's more than one way to print a list, but basically you say print a list and it will print us the entire content of the list. If I want to change the entry in position 1, for example, LST in position 1 is equal to 8, what will be the effect of this? The 4 will turn into an 8. Right? Yeah, the 4 became an 8. When we print it, yeah, now it became an 8. We can declare an empty list, we can declare a mixed list. When we print a mixed list, yeah, it will just print, you know, a string and an int, and then float, and then another string. And we can also declare a matrix. And when we print it, it will print the first element, which is a list itself, and then the second element, and then the third. And sort of one more thing I'm adding here is, right, we could use this notation before and then list, and we can also use this format notation. So format notation, we write F for format, and then inside a string, we can add variables in curly brackets. Okay, so let me put in there another example. Of format string. I will set x equals 4, I don't know, s equals abc, and then I'm going to print x equals x, s equals s. And it will print, yeah, x equals f4 and s equals abc. So whatever is inside, if we put an f in the beginning, whatever inside curly brackets will be evaluated to a variable. Okay, this is our first example. Let me show you another example. And the example will be, so here, last time we introduced functions, let's use these functions. Okay? So here we go. We declare a list of numbers, so the numbers, so these are the numbers. And I would like to write a function called print list. And what print list will do, and I'll have actually two versions. I'll have print list and print list v2, and I'll declare each of these. So here is my print list. So here is how it goes. For each element in the list, I'm going to print list in position I. Okay, so this requires some parsing. So we do format, and then we write just list, and I will be the variable. So in the beginning, I0 is equal to list in position I. So this entire thing is evaluated, and here only I is evaluated. And then I increment I by 1. Okay. So that's one way to write. Maybe that's not the best way. Let me actually change it to, let's add v1, v2, and v3. We'll have 3 different versions of list. Okay. First version will be the following. So I will set n to be length of the list. So length is a function that gets a list and returns the length of the list. And then I will say for I in range n, print list in position I equal list in position I. The second version, I iterate over the elements and I go separately. The third version, same thing with a while loop. So I set I to be length minus 1, and then as long as greater or equals 0, oh yeah, here I go backwards. So this is v1, this is v2. Okay, let's stick to v1 and v2. So these two are exactly the same thing, just iterating forward. Okay, one is using for loop on I, and the other one will iterate over the elements, and I sort of it iterates separately. In the beginning I is 0, then we need to increment I to be 1, and then increment I to be 2, and so on. Okay, so when we run this code, maybe we don't run the entire code, but only run it one chunk at a time. Okay, let's see. Let's go inside v1. We set n to be 7. Okay, our list has length 7. Right? And then we say for I in range n, we print 2, and then we print 4, and then 5, and then 6, and so on. In the end, we print these lines, and then we stop. Version 2, now we set I to be 0, and then we iterate over the elements without having the index I, right? So we iterate over the elements directly, so we need to know what I is, so we update I every time. But the result is exactly the same result. Okay. What will happen? What will be the effect when we set numbers in position 1 to be 8 and in position 6 to be 12? Oh, it updates the 8 here, and in position 6, 0, 1, 2, 3, 4, 5, 6 to be 12. This became a 12. When we print it now, yeah, it will print with 8 and 12. Here is another exercise. Let's say I want to print the list backwards. Print backwards numbers. We can print the list backwards. So this was the list, except that this was changed to 12, and this was changed to 8. How do we print it backwards? Well, we don't start with I equals 0, but rather we start with I equals length minus 1. Because remember, the indices go from 0 up to n minus 1, up to length minus 1. And then we say, as long as it's greater than 0, let's print the item in the list and then decrease I by 1. Okay, so in the beginning, I would be 6, and then 5, and then 4, and then 3, and then 2, and then 1. These are 3 functions for printing a list. Please look at these 3 functions. Good. Right. And one thing to emphasize, remember, the indices start at 0. So the last item is not numbers in position length, but number in position length minus 1. Right. Right. So we saw this example how to traverse through a list. And we did it backwards. Let's try another example. So here's an example. We have a list of grades, and we want to give 10 extra marks to everyone. Okay? So this is the grades, but we want to increase the marks by 10 points. Maybe before that, we'll do one more example. It will be called compute sum. Towards compute sum, we get the list of numbers, and we want to compute the sum of all numbers inside. How will we do that? Okay. I think it's pretty straightforward, needs to be done. We'll have the result. In the beginning, the result is 0. In the end, we'll return the result. What happens in the middle? We'll iterate over the items one by one. And for each item, we increase the result by this number. So let's try to do some debugging here. So this is our list, 1, 5, 76, and so on. In the beginning, result is 0. Element is, right, we take element to be 1. The result becomes 1. Next element is 5. So the result will be 1 plus 5, that's 6. The next element is 76. So we do 76 plus 6, that's what we get, 82. The next number is -3. So we update the result to be 82 minus 3. That's 79, I suppose, and so on. We iterate over the numbers one by one. Now we're at this number. So basically, in each step, our result contains the sum so far, and then we get the new item, and we add it to the result. And we add this one, and we add that one. This is the result, and then we print the result. So note that I did it here in 2 steps. Maybe it would be nicer to do it in separately. Somehow S to be this, and then print S. It's exactly the same thing. let's try this function called grader booster. We have grades, and we would like to increase all grades by 10 points. So how do we do that? We can do it using a, no, I don't like it. Here is how we do it. For each I in the range, we take list in position I and we increment it by this, whatever the increment should be. It's not necessarily 10%, but just any increment. Okay, so before these were the grades, we print the grades, then we run the grade booster, and then we print the grades again. Let's try. Maybe I'll write something like before. And here I'll write after. So this is what we had before, and this is what we have after. Okay, so we went to each grade and we increased it by 10. And it's all good. Each of them got increased by 10, including this 95 that got increased to 105. So maybe it's not such a good idea to increase it by more than 100. Here's what we're going to do instead. We'll write a version 2. How should we change our code so that it doesn't get increased by more than 100? So here's a suggestion. If it's already more than 100, here's what we'll do. If LST in position I is more than 100, then LST in position I, we just set it to be 100. That's all. Oh, sorry, I'm in the wrong place. Right there. That's our code. If we run it now, okay, but if we run with v2, then it will be kept at 100. Okay, and other than trying this exercise, I would like to emphasize the following. Lists are mutable, namely, I'm giving it into a function, and the function can change it. For example, this cannot be done with ints or with strings. Okay, for example, if I do try to change int, okay, x, I set x to be 4, and I will run this code, try to change, I'll write something like x t equals 7, and I'll try to change this case, both before and after t will stay 7. T will not change to 4, although it's really trying to change it to 4. Even if I change the name of the variable to x, it will not help, right? Why? Because we talked about it last time. It just this variable will be local scope and this will be global scope. So this will really just stay 7. So it cannot change int. Okay. We cannot change ints in a function, but we can change lists. Good. And same for strings. We cannot change strings. We'll talk about it later. Okay, but the point is strings, sorry, not strings. Lists are mutable. Okay, super important topic. Okay, good. This was another example. And again, this is from previous version. We need parentheses around the argument for print. Oh. Okay, so write a program that computes the sum of numbers. I think we did it already. And maybe there was more than one way to do it. Let's skip this example. Okay, write a program that takes a list of birth years and calculates their age and prints them. For example, if these are the birth years, then this is what we should print. Let me leave it to you as an exercise. Okay, so exercise for you, please do these examples. Okay, here's another example. Write a program that takes a list of numbers and checks, looks at all the numbers in the list and prints only the even numbers. Okay, so for example, if this is the list, it needs to print only the even numbers. Let's actually do this exercise. And in fact, I'll do a bit more. I will not only print the numbers, but I will put them into a new list. I'll create a new list that will contain only the even numbers. Maybe we'll do it in 2 steps. So first we'll have a function called print even numbers, and here's what the function does. It says, take your list, and for each element, if element modulo 2 is 0, print the element. That's all. That prints even numbers. Let's try only this. Okay, let's keep all the functions. This is A. This is the printing of A, and this is the printing of even numbers. So how will it work? For each element, right? We take 1. Is 1 even? No. Is 4 even? Yes. So we print 4. 9? No, not even. 16? Yes, 16 is even. So we print it. Next, what is it? 25? 25 not even. 28? 28 is even. So we print 28. So we'll go over the elements one by one. And again, look, this, the structure becomes quite complicated. There is the function, and there's the for loop, and inside there's indentation for if, and then the indentation for the body of the if statement. Okay, so print all these, and we have a for, and inside we have an if. I think by now we should be used to this. And we print 100, 81 we skip, and the next one we also skip, the 33. Okay. Here's the next example I would like to do. Next example I would like to do is isolate even number. What does it mean? It means we take a list and we would like to return a new list that contains only the even numbers. Okay, let me tell you how you do that. You start with the result being just the empty list. And this is what we're going to return in the end, the empty list. And then we go over all items in the list, all elements in the list. If it's even, for example, 4 is even, we append, so the function append takes the list and adds this element to the end of the list. Now the result becomes 4. We skip 9. What about 16? We add 16. It became 16. Okay. So this emphasizes the point that list is mutable in the sense we can modify the items. We can also add items to the list. Okay, and we continue, and yeah, 64 and 100. I think that's it. And we return this result. Okay. So B will be, what's B? B is this list. It's only the even numbers. Now we print B. These are the even numbers. Okay. Let's try another example. In this example, here's what we do. We would like to keep not every number, but every other number. Okay, and we'll put it in a separate list. So first result is empty. We set I to be 0, so I is the index. And for each element, if I is even, then we would like to append it. And if I is odd, then we don't want to append it to the list, to the result. Okay. So for example, we append 4. We skip 9, we add 16. We skip 25, we add 28. Here, 28 is in the list. Next, we skip 36, we append 33 to the list. Remember to always increment I because the for loop goes by elements. So, I is not being incremented. And so on. We skip 1, we add 64. Then we skip 100, we add 81, and then we skip 33. We return the result, and C contains every other number. It contains, right, 4 and 16 and 28 and 33, 64 and 81. And we print C. That's one way to write it. Maybe another way to write it would be something like this. N equals length of list. And for I in range N, we can just add result in position I. And then we don't do this increment because for loop will increment I for us. Yeah, that's also possible. Both ways are fine. That's a way to manipulate lists. Let's try another example. And it will be keep only even numbers in the list. Or keep only odd numbers in the list. So this is not keep. This is new list. So this puts it in the new list. And the difference will be that for keep only odd numbers, I would like, we will remove all even numbers from list. Or maybe, yeah, that's what we'll call. Remove even numbers from the list. Here I will add comment, creates a list, a new list that contains only even numbers of LST. This one creates a new list that contains only numbers in even indices, right? So we keep 2 in odd indices because we start from 0. Right, so this index and this index and this index and this index and this index. And now we're actually going to modify the list. Okay, so I'm going to write warning, the list will be modified. Okay. Okay, so how do we do that? So if list in position I modulo 2 is 0, then we take the list and I forget how to do it. So the operation is called pop, and I give it I, and we don't return it. So pop, remove the element in position I. Okay. Let's try this last one. Let's actually do some debugging to see what goes wrong, because something will go wrong here. Okay, so we print C, and then we have our A, and we would like to run it, and we run it. Oh, it says out of bounds. Oh no, something terrible happens. Let's try to run it again, and we'll try to see what exactly goes on. Okay. So let's see. First one, the first element is 1, that's fine. Now the next one is 4. So list in position I is even. So what do? We want to remove the number 4. We remove the number 4, right? This is what it was previously. We just remove the number 4. And now I becomes 2. So we jump to 16. You see what happened? So previously we thought we would need to take care of, right? Before that we did 4. Now we should jump to 9. But when we removed the item 4, everything got shifted. So now we're not looking at 9, we're looking at 16. Okay, if we look at 16, what will happen? So 16 is even. So first of all, we skip 9. 16 is even. We remove 16, and I becomes 3, which means we jump directly to 28. We skip 25. Well, that doesn't look right. The next number we look at is in position 4. 0, 1, 2, 3, 4. We skip the 36. Why? Because the list got shifted. So something went wrong here. You see what happened? Yeah, what happened is that we're shifting everything to the beginning of the array, to the beginning of our list, and things get shifted. So we skip some of the indices because of the shift. And even worse than that, the list becomes shorter. So initially n was 13, but we don't have 13 elements anymore. At some point, I will become 6 and 7 and 8, and it will say, oh, you're out of bounds. Why? Because you're thinking that n is still 13, but it's really just, but the list has already become smaller. It became 8 or 9. So my point is, if we want to do this, then something needs to change. Okay, then warning 2, it doesn't work. Because pop removes the elements in LST and it changes the length of a list. Okay. Here's a homework for you. Write, implement this function for m. Okay. And maybe we'll talk about it sometime. Okay. But we found even numbers and we could print even numbers, and we could find odd indices and we printed all numbers and odd indices. We did those. Here's another example. I would like a program that searches for a particular value in the list. So I would like a program called find. So how would find work? Here's how find works. Here's what find does. It gets a list and it gets a key. So key is an element. And it returns the index I that contains the key. Maybe there's more than one, it returns the smallest one. And if key is not found, the function is just return -1. Okay. So here is what we're going to do. Here is how we're going to write it. So let's say this is our list and key is 9. 9 is right here. So we set n to be the length of the list. And for each item one by one, if it's equal to key, oh, no, 1 is not equal. 4 is equal. No. 9? Yeah, 9 is equal to the key. We'll just return I. And if we went over all items and we haven't found the key, then we return -1. Remember, when we do return I here, it returns the index that contains number 9. And then we never, we don't continue with the function, right? We never reach this line. We don't go to the beginning of the for loop. We just exit here. Okay. And what is this print info function? So print info function is a small function that I wrote. It gets the array and it gets the key. Sorry, it gets the key and it gets the index, and it prints the info. So what's print info? It says, you know, if it's I is -1, meaning key not found. So it just says, if found in index, that then say it's in the position I, and if not found, just say it's not found. So I'm sort of using these functions, as you can see, and it's pretty convenient, right? So I'm saying find if I is in the list and print if it's found or not, and then print 10. So when I print 9, it will return the index 2. And when I print 10, it will say it's not in the list. Okay. Another example I would like is count. So what's count? Count is I would like to know how many times a number appears in the list. For example, 1 appears here 1, 2, 3, 4 times. So it says here the number 1 appears 4 times. How would you write the count function? Let's see. We again go over element. So we'll set counter to be 0 in the beginning. And then here's what we do. For each element in the list, if element is equal to the key, just increment the counter and then return the counter. That's all. Okay, so it's a very basic for loop that says, look for each element in the list. And if it's equal to the key, just return. And in fact, I should say that we wrote it ourselves, but there's a standard function list.count that does exactly the same thing. Okay, let's say we call it d equal list.count of a count 1. And it will do exactly the same thing. So it will say it appeared 4 times. Okay, both are possible. And I should tell you that for find, there is again a standard function called just index. And you should try using this feature. Okay, so basically it says if the key is in the list, return the first index, and otherwise we return -1, because this function crashes if key is not in the list. This is another example. Okay. So there is another way to write search, and there is a way to write count. Right, so count is sort of similar to summation, except that we don't increase by, I don't know, they're all kind of the same. We just, in count, we just increase by 1, and in summation, we increase by the value, but we increase by element. Oh, sorry, and in count, we also have the if, and I don't know, they all look kind of the same to me. Okay. I kind of showed you some list operations. Let's do a bit more. So one of them we said is called append. We already saw this one. So let's start with this simple example. So letters are A, B, C, D. So this is our list. If I print it, I print A, B, C, D. How do I access the 0th element? Yeah, I just print the 0th element is A. If I want to access the last element, I look at letters in position length of letters -1, right? Remember the -1. Why? Because the indices start from 0. So if our list has size 4, then the last item has index 3. I can add another item to the end of the list. How? I use append. Adding k to the end of the list. Here we go. When I print it now, it prints A, B, C, D, K. I can also, for letters, I can do this. I can append, I can concatenate two strings, sorry, two lists, and assign it, well, into the initial variable. Okay, so I write letter is equal letter plus XYZ. And when I print it, the list becomes ABCDK, XYZ. I can also remove an item from position 2. What will happen? The C is in position 2, right? A, B, C, 0, 1, 2. This is getting removed. And as we saw, it can cause issues because the list gets shorter, so you need to keep track of all the indices. Oh yeah, and there's another way to do it. You can also write delete del letters 2, and it will also remove the second item, which is in this case, right, the element in second position will remove D. So we get A, B, and then D is being removed, and then K, X, Y, Z. Okay, these are some list operations, some standard list operations. Let's do some more list operations. This is called slicing. One second. Sorry. So here's slicing operator. Here is what it does. Let's say I have a list of numbers and I print it. I can get a sublist of indices, let's say 3, 4, 5, so up to 6, not including 6. How? I write numbers, square brackets, 3 up to 6. It will give me 40, 56. So 0, 1, 2, 3, 4, 5. Okay, so it's up to 6, not including 6. Okay. So this gives me a sublist. Here is another way to get sublist of all numbers starting from index 2. If I write numbers 2 and then column, and I don't write the end, it will assume it's just the length of the list. Okay, so numbers in position 2 to the end, it's 0, 1, we skip them, 2 until the end. This is what we get. And if we want, from the beginning, the first 4 elements, we write numbers, colon, and then 4. This gives me the first 4 numbers. Yeah, it's sometimes pretty convenient. We'll see more operations on this and we'll work with this more. Okay, but for now, this is the slicing operation, this colon operator. And one last code example about list operations. For numbers, we can also do addition of numbers. So let's say we have A and we have B, and they're of the same length. We can print A, we print B. So A is 1, 2, 3, B is 6, 7, 8. And if we write C equals A plus B, then what do we get? C actually becomes, well, this is just as we saw before, right? So we concatenate the 2 strings. And another way to concatenate 2 strings is, sorry, not necessarily concatenate, but kind of duplicate. We take a list X and we write X to be X multiplied by 3. What will this do? It corresponds to same as Y is equal to X plus X plus X. Namely, this is X, this is X again, and this is X again. So for example, if I want to start with a list of 10 zeros, I can write 0 is equal to 0 times 10, and then I print Z. I get a list of 10 zeros. Specifically for zeros, I could also write, yeah, I think this also, no, you can't, doesn't work. I remember something like that. But anyway, this definitely does work. So I create 1, 0, and then I make 10 copies. And then I concatenate all of them together. Okay. This is your example about, these are your examples for list operator. Okay, there is append. We saw all these. Okay, we can append. Mm-hmm. So we'll see maybe this. Okay, well, let's try to do this example. So here is what we'll do in this example. We will want to write a function that takes a list and returns another list that contains only the 0th element and the last element. Yeah, let's try to do this one. Right. So it's called list ends. It gets LST. And the function gets a list and returns a new list that has only the first, the 0th, and the last element of LST. For example, on input 1, 2, 3, 4, 5, it returns 1, 5. Okay. So the right result will start with an empty list and will return the result in the end. And here's what we want. We would like to say result.append LST in position 0. And we would like to append this. I'm not sure what it's trying to do. Oh, it says, well, look, you can just simply do it like this. Sure, that's also possible, but will be right. So it basically says, look, this also works. I could do it explicitly. Okay, we do it explicitly, but it's also possible to do this. But there is one problem, right? So if list has size one, okay, here's the question. If length of LST is 1, then what will be the result? And question 2, if length of LST is 0, what will be the result? And if length is 0, what am I supposed to do? Yeah, I don't really know. I think I should not even return anything, right? So maybe I should say something like, if length of LST is 0, just return the empty list. And if the length of LST is 1, what happens? Well, answer will return the same element twice. Yeah, what can I say? But let's, to avoid this situation, we'll make an assumption. Length of list is greater or equal to. All right, and in this case, I don't know, we can write Z to be 1, 2, 3, 4, 5, 6, 7, 8. And then if we print list ends of Z, it will print 1 and 8, right? It created a new list. Maybe I'll call it ends. Ends will be 1 and 8. This is another example. All right, let's go to our next example. And the next example, here is what I want. I want the user to enter a bunch of numbers. And then I want to compute their sum. Here is how we do that. So in this program, we take numbers from the user. Then we print the numbers and print their sum. Okay. So first of all, we have a function called compute sum that we already wrote in the previous. We wrote it today. Okay. Yeah, that's the function. And now the main body. Okay, so this is the body, the main body of our program. We start with numbers being the empty list, and you remember we had this trick last time, so we'll have this Boolean variable continue that says as long as there is this user wants to add another number, we'll say add another number and another number, and we'll each time we get a number from the user, we append it to the list. We ask, do you want to continue? If the user doesn't want to continue, we set it to be false. Then we print the numbers, and then we compute the sum and print the numbers. Let's see if this works. Right, so now we are here. Please enter a number, I don't know, 10. Do you want to continue? Yes. Please enter another number, 3. Sure. I don't know, -8. Do you want to continue? No. And then, the numbers became 10, 3, -8, and the sum is 5. Let's do some debugging just to see that we understand exactly what's going on here. So cont is true. And we take n to be from the input, let's say 10. And now, so numbers was empty so far, but now we added 10 to it. Now we ask, do you want to continue? Let's say yes. So answer is yes. We check, is answer no? No, we don't go there. We continue to another one. Next number is 3, that's what we did last time. We append 3, so the list becomes 10, 3. Do you want to continue? Yes. Let's do one more number, -8. We append this number. Do you want to continue? No. All right, and then we do these 2 lines and test it. So the while loop, as long as cont is true, we go into the loop and we add numbers one by one, and then we exit. Okay, this is our next example. Okay, so another very important topic is to show how different variables point to the same list. And this will be actually pretty important, so I'm going to debugging here from the very beginning. Okay. So this is a super important piece of code. Okay. So we create A and we print A equals this. What happens when we set B to be A? So here's what happens. B and A point to exactly the same list. If I print B, yeah, it will print the same values, but not only that. Let's say I change B in position 0 to be 25. Look, it affects both A and B. If I change A in position 3 to be 0, it will affect both A and B. So after the change, both A and B have changed. Okay, so this is super important. When I assign A equals B, both A and B point to exactly the same list. When I change A, B changes. When I change B, A changes. So this is called aliasing. 2 variables point to the same list. Okay, now let's do something different. I'll set A to be this new list. And here's what happens. A points to a new list, while B still points to the previous one, right? B still points to this 25, 20, 30, 0. So here is A, yeah, it's the new one, and B is the previous one. What happens when I set B to be A? B also points to this new list and forgets completely about the previous one. Okay, the previous one, this one, it cannot be reached anymore. If I change B in position 0, it affects both A and B. right? Both A and B get 198 in the beginning. Right. So you may ask, okay, but if I want a different copy, so here is how we get a different copy. I take C to be A. Do you remember the slicing operator that we saw? It has no boundaries neither in the beginning nor in the end, which means I make a new copy of the list from the beginning to the end, and C will be a completely new copy. Now I print C. Yeah, this is C. You see A, B, and C both have the same, all three have the same values. But if I change C, it does not affect A and B. Right? A is not affected because here it means C is a copy of A, while previously B was an aliasing of A. Okay? So here B points to the same list as A. But here C is just a copy of A. Okay, it's super important. Sometimes it will be confusing. You'll say, oh, I'm changing this variable. Why does it change that variable? Remember the difference between copy and aliasing. Super important. I think we're done with the slides. So I have two more examples. Okay, but this example is really, it's as important as it gets. Okay, so again, remember this. Run this example one more time with the debugger, right? When we do b equals a, it means that A and B point to exactly the same list. When I modify A, B also changes. When I modify an entry in one of them, the other one also changes. While this just creates a new copy. I don't know how to emphasize a new copy of A. Same values, but it's a different list. Okay. While we're here, let's talk about string operators. So what is really a string? Right? You can ask, what's a string? You know, if you were a programmer and I were to tell you, you know what, we need to implement a string, how would you do that? So you would probably say, oh, a string is just a list of letters, right? A list of characters. So since it's a list of characters, we can apply all sorts of operations that work just like list of characters, just as pretend as if a string is a list of characters. For example, let's debug this one. S is hello, T is hi, we can print S, we can print T. We can access the first letter of S, we can access the last letter of S. We can do slicing. For example, if U is A, B, C, D, E, F, G, we can print U. We can print U from the beginning until the first two letters. We can print from the fifth letter to the end. We can concatenate the two strings just like we concatenate two lists. And this becomes our V. Here is one thing we cannot do. We are not allowed to modify our list. If we try to run it, it will do everything up to here, but then it will say str doesn't support item assignment, meaning I cannot change letters in a string. If I want to change it, the only way to do it is to create a new string. So you can think a string as an immutable list, not an array. Sorry, I'm using the word array because in other languages we use the words array. So strings are lists that cannot be modified. If we want a new string that has the first letter X, we can do, for example, T is equal X plus S from 1 to the n, and then print T. Right. So if we run this program, then yeah, T, the first letter is X, and then we take the substring not from the 0th letter, but from the first letter. Okay. So the first letter can change. That's another example. So these are string operators. Okay. So the important thing, strings are immutable lists of characters. And I cannot emphasize enough the word immutable. Immutable meaning we cannot do this. This is not allowed. Okay. And let's do one last example for today. We write a function that takes a list of strings and returns the longest string in the list. And let's say the list is not empty, because if it's empty, I don't know what to return. For example, if this is my list, then this has length 5, this has length 2, this has length, what is it, 12, I guess, 6. All these are shorter, so it should return hello world. Okay, how do we do that? We want, so let's declare a variable that will be called result. So how will we do it? How will we find the longest list? So we'll go over the items one by one, right, over the strings one by one. And each time we'll remember what's the length of the longest list. Well, but here we actually need to return the longest list. So how about we remember not only the name, but actually the index? We will remember the index of the longest list. This will allow us to remember both this, of the longest string, the string itself and its length. Okay, so let's call it max index. In the beginning, it's 0. And what we'll return LST in position max index. And then here's what we do. For S in LST, no. Let's say N is the length of the list. For I in range N, here's what we do. If length, if LST in position I dot length is greater than length of LST in position max int, then we found a new maximal index. Then we can return. Let's see if it works. Yeah, I printed hello world. But I'm not sure I need this index I. How about we try version 2, where we don't use index I. I would like to write something for S in LST. So here's what we do. I'll take longest string to be just list in position 0. And what I'll do in each iteration, if the length of the list is more than length of longest string, then I'll update the longest to be this. And I'll return the longest. Let's see if this works. Other than that part. Okay, so here's what we did. We took the longest string just to be, just the first item that we see, the first string that we see. And in each iteration, we will update it if necessary, if a longer string is found. Okay. So we go over all strings in the list, and if the length is longer than what we have longest so far, then we update it. Which one do you like better? Yeah, I'm not sure this one. I prefer this one because it doesn't use indices. It's kind of cleaner. But maybe it has, this one is a bit more intuitive. Anyway, both work. I prefer this one somehow. All right, this is all for today. I have a few practice problems. I will probably add some more and post everything online, but that's all for today. Thank you.